Goodness me, look at all those Cemvita t-shirts. It looks amazing. Well done. Before I start, I just wanted to say a personal word to Moji and Tara. Thank you for inviting me to join you on this journey. It's been amazing, and yeah, happy 5th birthday. I also wanted to say a big thank you to the Denver teams, both the ones that are here and the ones back in Denver. Thank you for being part of starting up the Biomining team. It was actually only 9 months ago that we opened our office. A handful of us opened it, and now, 9 months later, we've got a full lab. We're expanding the lab in the office. We've got a scale-up facility, and we're now well over 20 people. So, thank you very much for all your support and hard work. Okay. So today I'm going to talk to you about the two things, the mining and mineral processing industry and innovation, and why they're so important now for our energy transition and in the future. And then I'm going to dive a little bit into how Cemvita is working with mining companies to recover critical metals from low-grade waste resources in a low-impact manner to meet the demands of our energy transition and everyday lives in the 21st century. But first, a little bit about me and why this is a really personal mission for me. I'm an accidental miner. 25 years ago, as a young engineer, passionate about the environment, I worked in New Zealand for a couple of years, and then, as most Kiwis do, I went travelling to learn more about the world. And while I was backpacking through Africa with some friends, someone gave me a job in a big Rio Tinto copper mine in South Africa. And they asked me to pull together an environmental impact assessment just for 3 months. Those 3 months turned into 5 years. I became fascinated by the mining industry, the giant trucks, the massive crushing and grinding equipment, the conveyor belts that were miles long. The mine that we were in not only processed copper, but gold, silver, uranium. Yes, I worked in a yellow cake processing facility, and zirconia. I was amazed at the vast hole in the ground where the ore had been blasted and excavated, the huge tailings dams that held the waste from mining. The large rocks from both the open pit and the underground mine were crushed and milled from big-sized rocks that were blasted down to 100 microns. So 100 microns is about the thickness of one hair to extract the copper. This was a process that I later realised used 50 to 70% of the total energy consumption of the mining industry. But I'm proud to be a part of the mining industry. We impact every aspect of people's lives, from the machine that made your coffee this morning to the phone in your pocket, the pavement you work on, and the house that you sleep in, and much more. This is actually a picture of my team from the late 1990s in South Africa. We were commissioning a new zirconium basic sulfate plant. Zirconium basic sulfate is the stuff that goes into making fake diamonds, so cubic zirconia, and even things like deodorant. The product itself looks a lot like lithium carbonate. It's fluffy and white, and probably just as complicated to process and get it pure. The team here, together with the team, we took this process from the lab to production, and this is actually a photo celebrating our 1,000th bag of product. I'm also proud to say that the mining industry has been innovating. It's much safer than it was before, more efficient. The equipment and trucks are even larger and more automated. We have leveraged big data and machine learning to find and mine resources with more accuracy. But for the most part, innovation in the mining industry has been trapped by the underlying fundamentals of capital intensity and long-life massive ore deposits. These sunk costs lead to managers and executives selecting the safest innovation path, keeping the status quo, but improving maintenance, uptime, automating to remove decision errors, and leveraging economies of scale. This method of innovation has served the mining industry well for many decades, but it's now no longer enough. Our energy transition plans have a mining problem. The world doesn't have enough metals. Metals are increasingly in demand as the world electrifies and next-gen infrastructure is built. The supply-demand imbalance is growing and commodity prices are already spiking. Just this week, the Biden-Harris administration launched a $675 million program to address this, to expand the domestic critical materials supply chains, providing incentives to innovate in mining. The media release states global demand for critical materials is expected to increase by 400 to 600% over the next decades. For certain metal materials such as lithium and graphite, demand is expected to increase by as much as 4,000%. The drivers for disruptive change in the mining industry are starting to converge. A recent 2022 mining sentiment study reports CEOs are focused the most on just two problems: the ESG footprint of their products and how to supply the world's metal needs. This study headlines against a backdrop of record commodity prices and pressure for miners to boost their ESG credentials. The mining sector is seeking to position itself as a trusted partner in fighting climate change. The Cemvita mining team is focused on exactly these two issues, developing technologies to allow the economical, low-impact ways to supply the metal the world needs for our energy transition. In particular, the Biomining team are currently focused on low-impact bioextraction of minerals from low-grade and waste sources, in heap leaches and in situ. There are actually two innovative processes that the mining industry has been operating at scale for decades that I really like. They have very low capital intensity and low ESG footprints, but they haven't been fully leveraged. Perhaps there were some pieces of the technology that we're missing that didn't make it widely applicable across the mining industry. I think we now have those missing links. But first, let me tell you about these two innovative technologies. The first of these is bioleaching in large heaps of rock. These are big heaps. Some of them can be half a mile wide by another half a mile and 100 stories high. Actually, 20% of the world's copper is already extracted this way, so bioleaching in heaps of rock. And so rather than needing to grind the particles to, as I mentioned, the size of a human hair, big rocks are used, saving a large portion of that 50 to 70% of the mining industry's energy consumption, and very low capital intensity, as I previously mentioned. The second cool innovation on this slide is in situ leaching, or in situ recovery, ISL or ISR. It's a process widely used in uranium and has been used to extract copper to a lesser degree. And in situ leaching involves leaving the ore in the ground and recovering the metals by dissolving them and pumping the metal-rich solution or brine to the surface where the metals can be recovered. It's a mining process with little surface disturbance and no tailings or waste rock generated. However, the ore body does need to be, or engineered to be, permeable to the liquids and lixiviants that you're using, and located or engineered so as to not contaminate groundwater surrounding it. The mining industry will need to learn from adjacent industries such as the oil and gas industry to open up this technology to a wider range of ore bodies and metals. Cemvita and our biomining team eventually aim to combine these two concepts. So we're trialling biolixiviants right now on the surface. In the future, we want to go in situ. On this journey, Cemvita is focused right now on two key metals, one copper and lithium. The logic behind why we're focused on these two metals is several-fold. As you see in the graphs, there is a big supply-demand gap looming within this decade. The gap is wide and will provide opportunities for many companies to innovate in this space. Second, copper bioleaching is an existing process. It's already been proven at scale, but current recoveries for copper sulfide leaching are low. They're generally below 50%. So there's a big margin for improvement. Conversely, bioextraction of lithium clay is completely new and novel process and wide open for innovation. So we're trying to improve something that's already scalable as well as working on something novel and new. And lastly, in developing products to treat both sulfide minerals like copper and oxidized minerals like clay, we are actually developing biolixiviants that can be used across a wide range of minerals, sulfide minerals and already oxidized minerals. So now let's dive into what the fabulous team in Denver is doing in lithium and copper. As mentioned, copper bioleaching is a well-established process, but recoveries are low. So by using the latest biotech tools to first understand the microbial mineral interactions and then enhance them, Cemvita is aiming to increase the recovery of copper. Bioleaching microbes are pretty amazing. They're like algae. They consume CO2, but rather than getting their energy from the sunlight, they get their energy from oxidizing sulfur and iron minerals. A byproduct of that is the metals of interest like copper, zinc, cobalt, gold are released into solution. 70% of the world's remaining copper is in this form, the mineral is called charcoal pyrite. So what's the size of this prize? The world actually has I calculated it the other day, 1 trillion tonnes of copper still remaining on the ground in people's heap leaches that they haven't been able to recover all the copper. $200 billion of that is in the southwest of the USA, predominantly in Arizona and New Mexico. Cemvita is working to recover the remaining copper from those leach pads, plus increase recovery from freshly extracted ore. This year, Cemvita is conducting small pilot-sized copper bioleaching trials at our recently acquired scale-up facility, and we have plans to do field trials in late 2024. Now to lithium. So conversely to copper minerals, these are fully weathered and oxidized minerals such as nickel laterites are also similar to this, and our lithium clay that we're working on. These require microbial attack from organic acids and other enzymes to break down the mineral structure. You'll learn more about these microbial processes this afternoon when Marina, our head of fungal biotechnology and our lead of our lithium projects, presents. But briefly, this mechanism by which the microbes produce acids and enzymes to break down substrates is also a natural process. It's what they do to get the minerals that they need to function. Cemvita is leveraging this process to replace expensive sulfuric acid plants that are used for lithium extraction from clay. These biolixiviants bring economic and environmental benefits, as well as that they're much more selective, bringing only the lithium out of solution and leaving the magnesium and the calcium. Cemvita, our current stage, we're currently having promising results in the lab and are planning to move to pilot scale tank leaching of lithium clay in 2023. And finally, though we are working on leaching copper now from large heaps of rock and lithium clay in tanks, the mission, in my personal vision, is to move to in situ in the near future. I see a world where we no longer have massive holes in the ground and large tailings dams above ground. We instead have unobtrusive wellheads where biolixiviants are pumped into the ground to extract only the metals we need, leaving the rest intact. Remediation can then be simple by removing residual liquids and wellheads and then restoring the microbiome underground. We have a long path ahead of us and many technical hurdles to navigate, but we do have the right team and a wide network of supportive consultants, advisors, clients, and investors. So thank you all for your time and support both now and in the future. Thank you.